An introduction to SQL Select for the beginners. SQL, or Structured Query Language, is the standard language of the databases. We talk to the database using English-like statements written in SQL. Major Relational Database Management Systems, RDBMS, or Object Relational Database Management Systems, ORDBMS, such as Oracle, SQL Server, DB2, MS Access, MySQL, PostgreSQL, etc., use SQL as their standard database language. Other databases such as SQL LIKE, DuckDB, etc., also uses SQL for interacting with the database. Using SQL, we can create, update, delete, and query relational databases and tables. In this lesson, we will learn the uses of a few very basic SQL select statements. As this lesson is for the beginners, advanced select queries will not be covered here. Please note that SQL is not case-sensitive. Also, a single SQL statement can be written in one or more lines. Another very important point is that although the ANSI standard SQL implementation is the same for most of the database management systems, modern DBMSs or RDBMSs have their own additional functionalities in their version of SQL. In this lesson, we will use MySQL, but most of the examples covered here will run in other DBMSs or RDBMSs also. So let's begin. Let's first log into the MySQL server using the user credential of the root user. Although I'm using MS Windows OS here, the process is the same in other operating systems also. Here, the MySQL server version is 8.0.18. Let's select our database using the use command. Here the database name is test. Show tables command displays the table names of the selected database. Currently, these are the tables in the test database. We may quit the MySQL server using the exit command. We can select the database during login time also. Here test is the database name. We have successfully logged into the MySQL server and test is our selected database. Let's view the table names. So, we can log into the MySQL using this command. Or using this command. We may use the desk or describe command to display the structure of a table. These are the column names, data types, and other important parameters of the EMP table. Desk is the shorter version of the describe command. That is, desk and describe are the same. Now let's write our first select command. Here we want to display the EMP_ID and F_name columns of the EMP table. The select clause selects the columns and the from clause mentions the table name. Here the columns are EMP_ID and F_name and the table name is EMP. So, the command displays the EMP_ID and F_name column values from the EMP table. Just display the F_name column from the EMP table. If we want to display all the columns, instead of writing all the column names, we may use an asterisk in place of column names. Look, here all the columns are displayed. Now let's display the L_name column from the EMP table. Here 50 names are displayed. We may use the distinct keyword for displaying only the unique names from the L_name column. Now only 45 unique names are displayed. The distinct keyword has removed the duplicate L_names. Now let's display the gender column from the EMP table. All the 50 rows are displayed here. Place the distinct keyword just before the column name. Now only 2 records are displayed. Here is an example of evaluating an expression using select. No from clause is required here. We may also print a literal string using select. MySQL has a number of functions that may be used in SQL statements independent of tables. Here the function version displays the version of the MySQL server. Similarly, we may use the concat function for concatenating two or more strings, as shown here. We may use the now function to display current date and time. The current_date function displays the current date only, time isn't shown here. These are few examples of select without table names. We will learn more about functions later. Now let's look what happens if we display a literal and use the from table name clause. The literal will be displayed as many times as the number of records in the table. Here, yes, is displayed 50 times, as there are 50 rows in the EMP table. We may also display the column names of a table and one or more literals alongside other columns as shown here. Look, all the columns and the string literal is printed side by side. Let's give an alias for the string literal. Here the alias is accepted. So, yes will be displayed under the column name accepted. Oh, no. Forgot to put the table name here. Let's correct it. Displaying the EMP ID and basic pay from the EMP table. Now let's calculate allowances for each employee based on the basic pay. Here, the last column is a calculated column, it is based on the basic_pay column. Here, allowance value is 12% of the basic pay. Let's give a proper column name as an alias for the calculated field. Now it looks better. If the column alias has more than one word, put the words inside quotes. Let's also display the employee names by concatenating the first name and last name. Here the concat function concatenates the columns and any other strings passed to it as arguments. We may also use the keyword AS before the column aliases, but it is not mandatory. The allowance column has extra zeros after the decimal point. Let's round the numbers using the round function. Now the extra zeros are gone. Now we will use the where clause in our select statements. Let's display the records of the sales department only. Here the condition, department_ID equals sales, displays only the records where the value of department_ID column is sales. Similarly, we may filter out records for other departments also. Now let's try few other conditions for filtering out the records. Now let's put the various clauses of the select statement in separate lines for ease of understanding and for better readability. Here the select clause determines the columns to be displayed, the from clause mentions the table name, and the where clause sets the criteria for selection of rows. We may put more than one condition using logical operators such as and or. We will learn about operators in detail later. For mentioning a range of values, we may use the between and keywords in place of greater than or equal to and less than or equal to operators. We may use the like operator for matching strings using wildcard characters, % and underscore. Where % stands for any number of characters, the underscore stands for one character only. Here n% matches names that start with n, and any character that follows n are accepted. NA% means string should start with NA. That is, % stands for any character, any number of times. H followed by 3 underscores means string should start with H and 3 characters will be after it. That is, any 4-letter strings starting with H is accepted. N underscore I means the string should start with N, the second character can be anything, the third character should be I, and any character, any number of times, may follow I. Now let's execute few more queries with where clause. After that, we will learn the use of in operator. Here the in operator matches the values as listed inside the parentheses as acceptable values for department underscore ID. Not in is just the opposite of in, it negates the in condition. If required, we may rearrange the output of a query in ascending or descending order of one or more columns using the order by clause. Here is an example. Here the rows are arranged in ascending order of basic underscore pay column. We may also use the keyword ASC for ascending order. For arranging in descending order, we need to mandatorily mention it using desc keyword. We may also arrange the records using more than one column. Here the records will be arranged first by F underscore name, then by basic underscore pay. We may also mention ascending or descending for each column separately. Here L underscore name will be in ascending order and the basic underscore pay will be in descending order. Note that the columns will be arranged on the basis of L underscore name first. If the same name appears, only then the basic underscore AP field will be considered. Now let's move to our next topic, null. Null stands for absence of any value. Is null or is not null operators are used to check whether a value is null or not. Here we will use the context table. Observe that the email column and the mobile underscore no underscore 2 column have null values in many occasions. Now let's write a query to display the records where email is null, that is where email is missing. Now write another query that returns the rows where mobile_no_2 column has values, that is, not null values. Null and is null are just opposites. Now let's write few more similar queries. Now let's move to our next topic, the use of aggregate functions in select queries. Aggregate functions let us perform a calculation on multiple values and return a single value. That's why they are called aggregate functions. Those aggregate functions that we will learn here are count, sum, avg, max, and min. Count returns the number of occurrences of some values, and sum returns the summation of the items or the values of a particular column. Min returns the minimum value, whereas max returns the maximum value. AVG returns the average value. We may also use the distinct keyword inside the aggregate functions for working on distinct values. Here count distinct basic_pay returns the count of distinct values for basic_pay column. And, of course, we may use the aggregate functions along with where clause for calculating agreed values based on some condition. While writing queries using the aggregate functions, we can also use them in combination with the group by clause for grouping the results depending on the chosen column or columns. Let's count the number of employees for different departments. That is, group the result based on different department IDs. Department_ID is missing for 2 employees. Department ID is missing for these 2 employees. Here is another example. The number of employees based on gender will be returned by this query. We may also use more than one aggregate function in the same query. We may also order the result obtained from aggregation queries using the order by clause. We may also filter out the results of an aggregation query using the having clause. Here a condition is mentioned for filtering out the unwanted results. So far, we have learnt the basics of SQL SELECT statement with a number of examples in this lesson. Believe me, if you have understood the commands well, congratulations, your foundation of SQL is concrete. You will not face much difficulty in learning the advanced topics. That's all for today's lesson. If you find this lesson helpful, please don't forget to like, share, comment, and subscribe. Your valuable feedback is important for me and will help me improve the contents of the channel. Thanks for watching up to the end. Hope to see you in the next. Bye.